All right, page 4. We're going to practice finding the vertex, the x and the y axis, and the domain range, and sketch our parabola from these quadratic functions. Okay, so the first one is in the proper order. A equals 1, B equals -8, C equals 12. So if A equals 1, A is greater than 0, so it's positive. Therefore, the parabola opens up, and it has a minimum Y value. Just for a note, just for general size. I think some of the homework questions may ask you which way it opens, whether it opens upward or downward. Okay, so that's important to know from just the A, just from looking at that in the proper order. Then you need to find the vertex. So vertex formula. So a negative B, don't forget to double it if it's already negative, 2 times A, so 8 over 2, so it's 4. Okay, so heading for a vertex here. 4 is the x part of it. For the y value, we want to find, technically, you could put in f of 4. Would probably be better for that. And then everywhere there's an x, you're going to put a 4. So this is 16 minus 12 plus 12. That is not 16. What did I do? Oh, wait. It's not 12, it's 32. Okay, slow down. Which is 16 plus 12, which, and the minus 32, so -4, right? Did that really fast. 16. Yep. Okay, so that's -4. So that's my vertex right there. Okay, I'll draw this at the end. And for my y-intercept, x is going to equal 0. So when x is 0, 0 squared minus 8 times 0 plus 12, I'm going to have a y-intercept of 0, 12. And, I'm running out of space. I better write smaller here. Discriminant is to give me an idea of what this looks like. That's b squared minus 4, a times c. So b -8 squared minus 4 times 1 times 12. 16 minus 48. Not 16. 64. Okay, 64. 16. Okay, use your calculator if necessary. It's positive, so I should get 2 real solutions, right? Is it going to factor? It does factor. Positive 12. Positive need to. Yep. Okay. So x is going to equal 6 and 2. So that means my x-intercepts are 6 and 2. All right, what does that look like? It's going to open up with my vertex at, this is a sketch, right? Just a eyeball kind of thing. So this is going to go kind of like that, only much prettier than that. That's my y-intercept. It's 0, 12. That's got to be the lower one, so that's the 2, 0. So that makes this the 6 0, and that makes sense that this is at 4. My axis of symmetry goes through the middle, so this is kind of at 4, so 2 this way and 2 up would be 6, so that makes sense. So that's a good sketch of that one. This one, my A, it's in the proper order, so my A is -4, my B is a 4, and my C is a -1. So the parabola is less than, the A is less than 0, so the parabola opens down, and it has a max value, max Y value, right? So let's find it. All right, the B would be -4 over 2 times -4. So -4 over -8, that would be a +1/2, right? And then the Y, or the F of 1/2, would be -4 times 1/2 squared plus 4 times 1/2 minus 1. So this is, careful going through this. Orders of operation says you must do the half first. So this is going to be 1/2 times 1/2 is 1/4. Think about this as -4 over 4, which is a -1. This is a 4 over 2, which is a 2 minus 1. So -2 and a +2, that's going to give me a 0. So my vertex is 1/2 and 0. My y-intercept is when x equals 0. So f of 0 is going to be 0. It's going to be 0. Here, let me write it out. Show my work. So it's going to be -4 0 squared plus 4 times 0 minus 1. That's 0. That's 0. So this is going to be a -1. So the y-intercept is going to be 0, -1. And the discriminant, to tell me what kind of this answers I'm supposed to get, b squared minus 4ac. So this is going to be b squared minus 4 times -4 times -1. So this is going to be 16 minus 16 is 0. Okay. So that 0 means I'm going to have 1. It's going to bounce off the x-intercept. So let's find that 1. X equals -b plus or minus, the discriminant was 0. 2 times -4. So this is going to be -4 over -8, which is the half. Okay. So the x-intercept, where it's going to bounce, is 1/2. And 0, because all x-intercepts are 0 for y. So let's do what we can to draw this. It's going to be upside down, and it's going to bounce off a half and 0 as my vertex. And by the way, that's also my 1x-intercept. It's the same thing. All right, and since this is going to go down, you can see that that's going to hit at 0, -1 as my y-intercept. Oh, and I forgot my domain and range everywhere. Let's see. Domain is always, domain is the x's, right? This is going to go out. Oops, not 8. That's an infinity. It's going to go this way forever and this way forever. So the domain's always going to be -infinity, +infinity with soft brackets. And the ranges, this goes down. This has a minimum of -4 and goes up forever. This one goes down forever and has a max of 0. Yep. Okay, for Y value. All right. So after this, we're going to talk about the key points. These are the vertex and the Y-intercept and the X-intercept. So we're going to talk about these key points for the quadratic equations having to do with projectiles applications. Real-life situations with projectiles can be looked at in terms of time, number of seconds, minutes, or hours, and height. So time and height, usually, typically. The height's in inches, feet, yards, meters. Try to use your units as you talk about these things. And a object is dropped or thrown or shot up or dropped down, and the time it takes to get to a certain place from the ground. So the ground, or even where it starts with, you'll see some things on a cliff and some things shot up out from a certain, height. Like when you shoot something, if you're standing there with a gun, it goes not from the ground, it goes from wherever you're holding it. So it's, and then you're finding a certain place that it lands. Let's say, when is a baseball at 20 feet? On the way up or on the way down? When does it hit the ground after being shot up or dropped down? And things like that. So we're going to do that on the next video.